Welcome to the Crawford Family Forum. We are very, very excited to have the Planetary Society back for another Planetary Radio Live tonight. I'm curious, how many people here have been to an event in the forum before? Awesome, cool. About half of you maybe. How many of you have been to a KPCC event not in the forum, but somewhere else? All right, a few less of you. So for those of you who don't know, we do a lot of events all over Southern California, all different kinds of events. We do panel discussions and live broadcasts and screenings and parties. Yes, we do parties. And we now have a brand new name for all of these things that we do. We're calling it KPCC In Person. And you may have heard us talking about this on radio. You may have seen our Facebook page change, our Twitter handle change. And we just feel that this is a new name and a new brand that can really reflect what we are actually doing and how we're trying to engage with you all, our very valued community. So keep an eye out for that. Check out some other events that we've got coming up all over the place. You can do that at kpcc.org/inperson. And let's see, some other things before we get started. We will be, with our brand new Twitter handle, we will be live tweeting tonight, so you can follow along with us, join in on the conversation that way at our handles at KPCC In Person. And we'll be using the hashtag Planet9, which is also the password for our Wi-Fi, which is up on the screen. So log in, jump online, share your questions, your comments. We would love to hear from you and interact with you on that platform. I just ask, please turn your phone on silent and lower the brightness on your screen if you don't mind. Your neighbors behind you will thank you for that. It can be distracting. If you have any friends who can't be here tonight but were interested, we are live streaming the conversation on our website. So let them know they can join there. It will be archived there as well. So if you missed anything or you want to share it, you can go back and watch it anytime. And last but definitely not least, right before we get started here, I want to welcome Ashley Alvarado, who is our public engagement editor, and she's going to talk to you guys about those little pieces of paper that are on your chairs. Ashley.
Thank you. So it's really nice to see some familiar faces in the room. I am the person behind the paper on your chair and the golf pencils, which are not to keep. The reason we have these papers is it's sort of an extension of why we're KPCC In Person now. We are working really hard to reach out to the community. We have people that we've talked to who end up in videos when we're talking about what's that issue that you care about the most. We have people that we're bringing together for lunches to talk about certain issues, whether it's, let's see, tomorrow I'm doing a lunch where I have members of the Muslim community here coming in to just sort of talk about what are we getting right, what are we getting wrong, what can we do better as a newsroom. And then I have millennials coming in on Thursday. I've learned millennials are very exciting to know about. We watched a video today. It's like National Geographic. But these papers are a great entry point to all of that. So if you would like to see what a pencil does and to write a little bit on the paper, tell me a little bit about you, whatever's kind of interesting, whatever you feel comfortable talking about. Maybe you have a band. Maybe you killed a planet. Maybe you make really good chili. Anything that you're interested in talking about, write it down. It's interesting to me. And you will get emails from me once in a while, not that often, I promise. Thank you.
Thanks, Ashley. That gets better and better every time she does it. And now, without further ado, I'd like to welcome the host of Planetary Radio, Matt Kaplan.
Get started as close to 7 o'clock as possible, straight up for the folks in the webcast audience. Thank you all for coming out. Who's been to a Planetary Radio Live before? Wow, quite a few people. How many members of the Planetary Society? Not bad either. Well, thank you. Talk to the people next to you who didn't raise their hand. We're going to have a good time. Got an amazing panel and a terrific couple of topics, starting with Planet 9 and broadening out from there. You will have a couple of opportunities to participate tonight. We're going to have a competition. There'll be objects up there on the screen, and you guys will be able to raise your hand. If I call on you and you're the first one who's right, you will get a Planetary Society asteroid. Yeah, that's the right reaction. And then, toward the end, we will also open it up for questions. Now, we won't do this for the competition, but for the end, when you have questions for the panel, first of all, please don't come up with a lecture. Just ask us a quick question, and we'll turn it right over to the panel. We are not going to get to everybody who's got a question, but we'll try and do as many as we can. Now, in addition to that, for the first time, at least for us, we're going to be taking some questions from the listening audience, the viewing audience, the people watching the webcast. So that'll also be a piece of the Q&A. There's one more opportunity for you to participate, and this is going to be for Bruce Betts, who you'll hear me say that's the one disappointment tonight, that Bruce was unable to be here. Well, he will be here on screen, as you'll see in a few minutes, but I need an introduction to the random space fact that we normally do as part of the show. So we'll practice it once now, but you'll hear me do it again later, and it means all of you have to join in on this, okay? I'll say on 3, you're going to say, "Hey, Bruce, I got your random space fact." Hey, Bruce, I've got your random space fact right here. So that's hard. That's a tough one. Let's practice it once. 1, 2, 3. Hey, Bruce, I got your random space fact right here. Perfect. He's going to die. He's going to fall off his chair. Okay, that's it. Please, if you feel the need to be enthusiastic in your support, applaud, cheer, do whatever you want. Just don't boo or hiss. You can do that later. A couple of things. We've just hit 7 o'clock. We've got a number of space celebrities in the audience. I won't get to all of them. Over here, Tom Spilker, another famed explorer of the solar system. Wave, Tom. He's lucky enough to be married to Linda Spilker. Dave Doody is here. Dave Doody, also of JPL and the Cassini mission. Dave teaches a class, an amazing class at Art Center College of Design. Starts up again in May, right? That's right. Oh, he's selling. Basics of Interplanetary Flight. It's truly amazing, and it's for lay people like you and me. That's it. We're pretty much ready to go. It is 7:01. I'm going to be staring down at the iPad periodically, and I guess we're good. And we have one more. I don't think he'll be a surprise, but maybe to some of you, a surprise guest who I'll open the show with. Dave, we're all set whenever you are.
Great. You're good to go.
Anytime.
Oh, so you want to go with yes?
Oh, no, I'm okay. I'll jump in. I didn't know. You don't have to put him up yet.
Oh, okay. Then you're good to go.
I'm good to go. Okay, I was afraid I'd be stepping on music or something. Okay, we're already going. People are watching us. Hello out in TV land on the webcast. Welcome to Planetary Radio Live. I'm Matt Kaplan of the Planetary Society. This time we are headed for the edge of our solar neighborhood with several of my favorite people on this pale blue dot. Planetary Radio is the weekly radio show and podcast series from the Planetary Society, of course. When we get tired of sitting in, windowless audio studios, we often end up right here in Southern California Public Radio's headquarters, specifically the Crawford Family Forum, where they have hosted us many times. And we are going to be joined, we are joined today. Let me make sure. Yeah, definitely. Are we joined by a bunch of space geeks? Good reaction. Just making sure. So Mike Brown and Konstantin Batygin are the Caltech researchers who have pointed the way to a new world, a big one that they call Planet 9. Astronomers around the world are just itching to be the next Frederick William Herschel or Clyde Tombaugh or, Mike Brown, and be the first to find and image this world. We're going to bring them up in a couple of minutes, but we'll also later on today have Cassini project scientist Linda Spilker. She'll be part of a broader discussion about our diverse and growing solar system. First, though, I have a couple of colleagues to introduce, beginning with somebody you know. Ladies and gentlemen, coming to us from New York via Skype, it's quite late there, of course, here is the CEO of the Planetary Society, Bill Nye the Science Guy.
Greetings.
Welcome, Bill.
So when you guys do random space fact?
They're just going to do the introduction.
Oh, I know. I'm very hopeful that Bruce doesn't die. That seems...
that would be a sad way to go, but...
yeah, well, it might be... it might be his live stream, but I wouldn't count on it.
So
Anyway, thank you for your support, everyone. Thank you for coming. And we're going to talk about a topic that fascinates everybody. What else is out there? Planet 9.
Bill, you've known Mike Brown for quite a while, haven't you?
Oh, wow, yeah. Oh. Yeah, I met him a few times. He's been very gracious to me.
Were you relieved to learn that we may once again live in a 9-planet solar system?
I never had a problem with that either way, you guys. I love you all. I have many, many things that concern me. When people say use the nominative pronoun as a direct object, I'm very troubled. But between you and me, when Pluto was its preeminent status was questioned and it was reduced to a dwarf planet, I was okay with that. Those astronomers have dwarf stars, so they got a dwarf planet. And by the way, for the radio record, I am supportive of the term Plutoid. Instead of being the last of this class of the traditional planets, it's a new class of objects named after Pluto, the Plutoids, all out there. And I don't know that much about the potential Planet 9, but I assume it is Plutoidal. So
actually, I think we may learn later that it's quite a bit more than Plutoidal.
It's like it's a whole other thing.
Yeah.
Yeah. It's ninoidal or something. Yeah.
But you're still fond of Pluto, right?
Oh, it's even more fond. 7 geologic areas, potential for an atmosphere, beautiful sphere. What's not to love?
We're going to find out a little bit more about what to love when I bring up our next guest, but I'll first mention that Bill can be heard on Planetary Radio most weeks, just like my next guest. She is the Planetary Society's senior editor. We also call her our planetary evangelist. She's a contributing editor to Sky and Telescope magazine. You may have caught her providing expert commentary on now a host of national and international news outlets. She has taken a break from writing her soon-to-appear book about Curiosity, the Mars Science Laboratory, to join us this evening. Please welcome my friend and colleague, Emily Lakdawalla.
Thank you, Matt.
So you can also tell us, why have we once again gotten confirmation that Pluto deserves our respect?
Well, Pluto never lost any deserving of respect. Pluto has always been a fascinating world. We knew from a distance that it was multicolored. We flew past it up close, saw it had this amazing diversity of terrain. But with all of this focus on Pluto, we forget why its status changed, which is that there were all these other amazing worlds out there that we recently discovered that we know are also colorful and changeable. And they have fantastic names like Eris and Quaoar and Varuna and Ixion and Sedna and 2007 OR10, which needs a name.
We're going to keep right on going because we do want to get our next two distinguished guests up here. But as part of introducing them, we're going to show you a little video that Caltech actually produced to introduce people to Planet 9 and these guests. So I think we'll go ahead and roll that now.
What we have discovered is that numerous features of the Kuiper Belt, a field of icy debris beyond the orbit of Neptune, can be understood if the solar system possesses an additional 9th planet that resides well beyond the orbits of the known planets.
When we looked at the outer solar system, we realized that while most of the very distant objects, these objects beyond Neptune, beyond Pluto, most of these objects, they all go around the sun and they're all sort of pointing off in all different directions. But the most distant objects all swing out in one direction in a very strange way that shouldn't happen. And we realized that the only way we could get them to all swing in one direction is if there is a massive planet also very distant in the solar system, keeping them in place while they all go around the sun. And we started looking at this and thinking, this must be either a coincidence or it's caused by something else. It can't be caused by a planet because that's crazy. There are no planets out there. I went from trying very hard to be skeptical that what we were talking about was true to suddenly thinking, oh, this actually might even be true.
So the object itself likely is more massive than the Earth, probably a little bit less massive than Neptune. It sits right in between that terrestrial to giant icy planet range. Its orbit, unlike the orbits of the known planets, is not nearly circular and planar. Instead, it is exceptionally wide, 20 times bigger than the orbit of Neptune. The orbital period of the Earth is, of course, 1 year. Right? The orbital period of Jupiter, the big player in our solar system, is about 10 years. The orbital period of this putative ninth planet is 20,000 years.
We have nothing like it in the solar system, so it's new for us. It is, however, the most common mass of planets that have been found around all of the other stars. People have always looked at all these other planets in this strange mass range and said, wow, I wonder what these are. I don't know what these are because we don't have anything like it in the solar system. Looks like maybe we do. There are many telescopes on the Earth that actually have a chance of being able to find it. And I think that many people will be inspired to use their telescopes. I'm really hoping that as we announce this, people start a worldwide search to go find this ninth planet.
History shows us that it's a bad idea to consistently say we have now reached the end of the solar system and there's nothing beyond what we already know.
And all those people who are mad that Pluto is no longer a planet can be thrilled to know that there's a real planet out there still to be found.
All right, let's get these guys up here, beginning with the best-selling author of How I Killed Pluto and Why It Had It Coming. If you look for the book on Amazon, sorry, Mike, I already used this joke on you, be aware that he is not the Mike Brown who wrote Making Adult Videos for Fun and Profit. Mike is the Richard and Barbara Rosenberg Professor of Planetary Astronomy at Caltech, the California Institute of Technology. He's been on the faculty there for about 20 years, and get this, he was recently awarded the Richard P. Feynman Award for Outstanding Teaching. He corrected me last time he was on the show when I said he has been on the discovery of more trans-Neptunian objects than any other human being. So, to be more precise, he has been on the discovery of more of the big objects found beyond Neptune than any other person. Here is Mike Brown. Konstantin Batygin is an assistant professor of planetary science at Caltech, where he does much more than point the way to new worlds. He's fascinated by the challenges involved with understanding how our and other solar systems formed, and by what's going on in planetary atmospheres, and even diving deep inside those worlds. Now, just a month and a half before he became world famous for working on the Planet 9 stuff with Mike, he was the lead author of a paper titled In Situ Formation and Dynamical Evolution of Hot Jupiter Systems. When he's not thinking deep thoughts about our and other hot solar systems, he may very well be fronting for his hot band, the 7th season. Please welcome Konstantin Batygin. Thanks for being here, guys. Mike, that's the hat I said I would eat on this stage if you came up here and told us you'd found Planet 9. Do I have to start chewing?
No. So sadly, we were at the telescope. I was at the telescope on Friday night at the Subaru telescope. You saw the picture of that on the screen, and it is. I would bet that's going to be the telescope that finds Planet 9. But it's going to be a long search. So we just had one night. Unlikely we found it in the first night, and we're actually still downloading the data. There's so much data. So you don't have to eat the hat.
Bill, I know you have to leave us pretty soon here after, like we said, a very long day there in New York. Did you want to throw anything at these guys before we say goodnight to you?
Well, I mean, the thing that I find so intriguing and is that this orbit goes, how to describe, way north of our sun. It's way out of the plane of the ecliptic or what have you.
It's tilted by about 30 degrees compared to the orbits of the other planets. And so as it travels out to its extreme distances, it is quite a bit above the plane of the solar system. And we think we even understand why. We think it probably was scattered out of the solar system. It formed early in the history of the solar system around Uranus and Neptune, got a little bit too close to Jupiter or Saturn, and got scattered out there. So it's a very, as strange as that orbit looks with its very eccentric orbit, very tilted orbit, it's kind of a natural outcome of how we think it got there.
Can you compare that to the tilt of Pluto's orbit?
I could, but it's just Pluto. Who really cares?
Hey, Emily, maybe you can help out. You care about Pluto?
I care about Pluto. It's a really awesome world. But, it's an awesome world among a great many awesome worlds.
It's tilted by 19 degrees, if you have to know.
So this is 1.5 times as tilted.
It is. And I would like to point out it's 5,000 times more massive, just to put it in perspective.
Planet 9 is.
Planet 9 is, yeah.
Yeah.
So how much is that in Earth masses?
It's about 10 Earth masses.
So when I'm forming a solar system, let's say I'm a cloud of interstellar dust. Why doesn't everything end up in the middle? How do these things get slung out? It just seems like there'd be a lack of angular momentum to make stuff like this happen.
Konstantin, that might be one for you.
Well, Bill, I mean, look, the young solar system is a violent place. It's not a place where everything.
Oh, tell me about it.
I will. That's what I'm trying to do here. It's a place where newly formed planets don't just stick around on the orbits where they have formed. They kind of migrate, and in fact, that process of convergent migration always is sort of invoked as the means of allowing planets to get too close to each other and suffer a close encounter. And really, there's no real problem with the angular momentum budget. It's actually kind of interesting. The angular momentum of Planet 9 is roughly equal to the rest of the angular momentum of the solar system. So they're roughly split half and half. It's almost a natural outcome that you expect when you scatter things out and they get kind of perturbed around by passing stars.
So, wait a minute. Is there a planet 10 that's of comparable mass someplace?
Well, I mean, look, the solar system, in terms of real estate, right? It has plenty of it. The sun's gravitational sphere of influence ends at around 100,000 astronomical units, whereas the orbit of Planet 9 only swings out to about 1,000. However, at present, there is no evidence for any additional bodies beyond Planet 9. So it's not that there couldn't be a Planet 10, a Planet 11. It's just that there is no evidence for them at the moment.
And it's because the evidence that we have for Planet 9 is these very most distant objects we can see in this region of the Kuiper Belt. To find any evidence or evidence against Planet 10, we need to find objects even further away. So that's really going to be a task for the next generation of telescopes.
Yeah, you got to do it.
You
got to do it.
Working on it.
Do it.
Bill, I promised to get you to bed by curfew tonight, and so I want to thank you for being part of this for a few minutes, and I'm sure the crowd here feels the same.
Well, I thank you, man. I just want to thank Konstantin and Mike and Emily for coming out in the evening. I know you have day jobs. And I just want to thank the audience for taking the time to come. We're at another crossroads in planetary exploration. I mean, if you told me 30 years ago we'd find Planet 9, I would have been quite skeptical. So we're at a new age of discovery. And you guys are leading the way, and I think we really appreciate your good work. Carry on.
Bravo.
Thanks, Bill.
Thank you very much, Bill. He is the Chief Executive Officer of the Planetary Society, Bill Nye, the Science Guy. Good night, Bill.
Good night. Carry on.
Can we bring up, I don't know if we're going to be able to pull this up immediately, but hey, poor Dave McKeever, who's the head tech guy here, I keep him running. Can you go ahead and put that beautiful artist conception up on screen? There it is. I just want to, give credit where credit is due, first of all, that this actually comes from another Caltech astronomer, Dr. Robert Hurt, who works in the Spitzer Space Telescope Institute, I think, if I got that right. That's his artist conception. What did you guys think when you first saw this?
It's spectacular. So, he asked us a few questions about what it should look like and how far away it was. And he then put this together sitting in front of the Milky Way, far, far away from the sun. And he even added a little bit of lightning on the dark side, which is, of course, pure speculation, but it may well, if it's a gas giant like this, it probably does have lightning going on like that. So if you could sit back on, let's pretend like we're sitting on its moon, looking back towards the sun, you would see a view sort of like that. We don't know if it has a moon either, but if you were there, it'd look like this.
When it's discovered, if it looks anything other than this picture, I will be just heavily disappointed. What? What?
Is that? I mean, that's our sun, right? That little star
that's
in the
right,
distance
yeah.
there, and that it looks like a cloud of dust around it.
Oh no, it's sitting in front of the Milky Way galaxy. So it's actually when Robert does these, he does these geometrically accurate. So you're seeing the real star field. If it were in the position that it is, you see the real star field behind it, the real sun at the real brightness. It's all.
Not the Milky Way, but if I understand.
Oh, around the sun.
Just around the sun itself.
Around the sun,
yeah.
you see a little bit of glare. Some of it would be from the zodiacal dust around the sun, but I think that's probably what he's showing in there.
Lens flare from the
Lens
spacecraft
flare,
that's
yeah.
orbiting Planet 9.
Yeah, that's right.
Emily, did you want to get in?
I did. Well, you guys have written a really excellent paper, but I do want to make sure that the audience is aware that you haven't discovered a planet yet. You've come up with an excellent argument for the possible existence of one. Can you talk about what you're more, if it exists, what characteristics you're more sure that it has, and which ones are less well predicted by your paper?
Well, I think that given its mass range, right, we're pretty certain that this is not a rock, right? This is not a rock or an ice ball. This is a object with substantial amount of its mass in rock and ice, but it's surrounded by a thick hydrogen-helium envelope, kind of like Uranus and Neptune. We are also, this is speculative, but we would be surprised if it didn't have a system of moons. Every giant planet in the solar system has a system of moons. There's no reason why this object should not.
I don't know. I can think of reasons why it wouldn't, but it'll be interesting to see if it does.
Your reason is wrong.
Yeah, no.
Because
I don't know.
I can tell you, I was in the office at Caltech with these guys for a while. They do this a lot.
I would like it to have a moon, but I actually would not be surprised at all if it didn't have a moon.
I'd be surprised. Look,
Yeah,
moons
you're
sit
easily surprised.
so close so compactly in the hill
Well, just
sphere of
look
this
at
object.
Neptune, though. How many big moons does Neptune have? It has one, and it probably didn't start out at Neptune.
Oh, I don't want.
It
big
probably
moons.
started out with more, and then that one got rid of them.
Right.
Yeah, so who knows? But it might have moons. But I think Emily was getting more at not what we speculate the most, but what we really, really know. And so one of the things I think we really, really know is its mass. So we do think it's about 10 Earth masses. It does not have the effects that it needs to have if it's under 10 Earth masses. It actually might be more. It could be 20. It could be bigger than Neptune. We're still exploring the upper limit. And the other thing we know is that orientation of the orbit. It has to swing out in the direction that we showed, and it has to come in close to the sun. We're talking 200 AU from the sun. That's now my new definition of the inner solar system is anything inside of 200 AU.
So just for comparison, Neptune is at 30 AU.
Yeah.
The Voyager spacecraft are currently at 100 and 130 AU.
And
Yeah, so
AU, everybody, astronomical units, the mean distance of the Earth to the sun. Okay. Sophisticated crowd. You all knew that.
So we know that pretty well. We don't know how far out it goes. We show that elliptical orbit, but it could go a little bit, come a little closer, could be a little further. It does all the interesting effects when it's close. So we know the close distance pretty well. The further one is tough.
Is there any way to guess at how long the search may take? I mean, could somebody, one of your competitors or you, say tomorrow, you see this one?
Yes.
That's it.
Oh yeah.
Yeah.
How about at the outside? What if it's really hard to find?
So the search is really well underway right now, and there are when it's close to the sun, close 200 AU, when it's just at the edge of the inner solar system there, it's really pretty bright. It's bright enough that there are people in town who have telescopes in their backyard that are big enough that they could see it from around here. If it were close at its closest approach to the sun. No one has seen it yet, which is a pretty good indication that it's not at its closest approach. And we've actually done some pretty good telescopic surveys that would have seen relatively bright objects. Mostly these near-Earth asteroid searches would have found it if it were in a sort of close swath around the sun. So we've ruled out about half of its orbit. And so that it could have been found in any of that half of the orbit. It would have been found already. Yeah. So it wasn't found there. We have some other surveys that we're looking at old data that could rule it out. But really, I think it's going to take this big search at the Subaru telescope. We just put in a proposal. You still have to ask nicely. Let them please let us use your telescope. We think that we can find it in a 20-night survey with the Subaru telescope over the next 2 years. And I would be willing to bet that it's found over the next 2 years. I used to answer that question by saying 5 years, but now we've ruled out so much of the sky already. I think it'll be 2 years from now. We'll be sitting here talking about Planet 9 instead of the search for Planet 9.
Yeah. Unfortunately, from just the way that eccentric orbits work, it's most likely to be in the outermost part of its orbit. It spends most time at its kind of furthest away part from the sun. So that kind of the natural expectation there is that it wouldn't be in the part of its orbit where it has been ruled out anyway by observational.
So it's just like a comet, which is comes in pretty close to the sun, but not for long.
Exactly.
Yeah. Okay.
Now, if I wanted to prove you wrong,
Yeah.
how would I go about doing that?
Easy. So it's this is one of the things that's nice about this prediction of Planet 9. It doesn't just predict that there's a Planet 9 out there and then nobody finds it and I say, well, you just didn't look in the right place. It's this. We also predict that there will be very specific set of other objects in the solar system, in the outer solar system that you find. Specifically, you'll find a lot more of these objects. Planet 9's orbit is like this. And then there were all these other Kuiper Belt objects that went like this. There will be many Kuiper Belt objects like this. There'll be very few that go off like this in these other directions. If you start to find a lot of those, we're just wrong.
Let's put up that next slide, which actually, you saw this in
There we
the
go.
animation a few moments ago, and it shows a lot of those so-called trans-Neptunian objects, including several discovered by Mike. And there's Planet 9 way off on the other side.
And now what I think is cool about this is that if I wanted to set about proving you wrong, and I turned out to be wrong, and you turned out to be right, I would at least have discovered a whole lot of other worlds out there in the distant solar system. So that's cool.
Yeah.
It's a consolation prize.
Yeah. And Emily, the alternative route you could take is you could go through my math and try and find a minus sign error. I make a lot of those. I make an even amount, so they all cancel out.
Konstantin, what kind of calculations went into your contribution to this, figuring out, yes, there's something out there and it's following roughly this path?
Well, we ended up doing a whole hierarchy of calculations. Actually, our starting point was not too different from what was done by Leverrier, the theoretical discoverer of Neptune in the mid-1840s, right? Who used just sort of pencil and paper, what's called perturbation theory, right? Just working with the governing equations of the motion of planets to infer the existence of Neptune. So our first models were really just pencil and paper, and
No supercomputers at that point.
no supercomputers.
Also, I'd like to point out that those were all wrong.
Because of the minus signs.
Yeah, no, but they were. They got the wrong answer.
That's right. Einstein went through the same thing.
Yeah, look, I mean, they were an important starting point because what they had shown is actually that the planet hypothesis is actually a feasible thing. It's a promising avenue to go. Interestingly, what they were suggesting is that the orientation of the planet is 180 degrees away from what this picture shows. They were showing that the planet should be aligned with this group of Kuiper Belt objects. And then, really to put these kind of analytic models to the test, that's when we went to the supercomputers, where we were able to explore in a lot more detail what's going on. That's how we.
But for me, the really important part of the pencil and paper calculations was that's where it became obvious that there had to be a very eccentric planet.
Indeed.
Until that, people had talked about maybe there's a planet out there, maybe there's not, who knows, and nobody really had any ideas of what it might be like. But those showed very quickly that if it's not eccentric, it's not very eccentric, it's not going to do anything.
It just doesn't. So the key is that if it's not eccentric, that alignment that you see on the screen, it goes away on geologically short timescales. You can't wait 100 million years and it's gone, right? So it's
an instant.
Sorry,
it's nothing. It's an instant.
Yeah. I don't know. So it's the torque from this eccentric orbit that's keeping these orbits confined.
Mike, how much of your competition is out there racing to find this world right now?
We're actually trying very hard not to turn this into a big competition.
Sorry,
as much
colleague.
As
how many of your colleagues are out there?
So there are I would say 3-4 viable groups who are likely to find it first. So one of them is in this. So it depends on where it is, actually. So we think it's probably in its most distant regions, in farthest from the sun. If it is farthest from the sun, I think we'll find it with this Subaru survey, if they give us the time on the telescope. Any of you involved in the Subaru telescope? No.
Can you put in a good word?
It's too bad. So Subaru telescope is not from the car company. It's the Japanese national telescope. Subaru is the Pleiades in Japan. So that's what their telescope is named after. We have a very large group that we're working with from Japan, who are all working together to try to get this going. So I'd say we have. I would give us a greater than 50% chance, but not greater than 60% chance. So the other groups are in the southern hemisphere. There's a large survey that's been going on called the Dark Energy Survey, and they use the dark energy camera to do dark energy science. And
they're on the dark side.
They're on the dark side, and they have an entirely different reason for existing. But as soon as we said, hey, Planet 9 is out there, and by the way, its path goes right through your survey field, they got very excited and started looking. So they may have a good chance of finding it. There's a wild card, which is that it might still be a little bit brighter than we expected, and it might be found in this big survey being done out of Hawaii, Pan Stars. They should have found it already if it were to be found, so I don't think they'll find it. And then the other ones are the other group of astronomers who are looking for it are Chad Trujillo and Scott Shepard. Chad used to be a postdoc with me, lived here in Pasadena, and they found one of these objects. They found 2012 VP113, and they've been looking for more things like it too. They have a smaller survey, and so they, but you can always just get lucky. You can have a very small survey, and you look in the right spot one day, and there it is. So maybe we already found it last Friday night, and we just haven't looked at the data yet. You could still eat your hat if that's true.
No, I'll hold off for a while. You guys know that I'm bothered by the thought that if somebody else does make this discovery, they're the discoverer of Planet 9. They're going to get first dibs on naming it.
Let me ask you a question.
Yeah.
Who discovered Neptune?
Leverrier, Kate did what you guys did, right?
Yeah.
Help me, Emily. I can't think of his name. You're right.
I rest my case.
Now look, we theoretically licked Planet 9 already. Okay. Whoever wants to eat it now is going to have to deal with that.
I love it. Before we go on, and we are going to go in a moment or two here into a new section of the show, I want to talk about just, the team that you guys represent. One of you more a theorist, one of you more an observational astronomer. That's right. Does it work out pretty well? You seem to have a good time.
So good. It just works out so good. Yeah. No, look, we have an awesome time. Together. We argue a lot, but in the end, it's only because we hate each other.
We argue until you realize that I'm right, and then we stop arguing.
Yeah, that's like. That's sort of like what Mike dreams of, Anyway, look, I mean, in all reality, though, it's such a pleasure to be working with Mike. Mike has an exceptional, physical intuition, right? He simultaneously is very well grounded, not just in reality, but in observational reality, and that's something that I need, right? That's something that I need in a partner, right?
And as I always say, that pencil and paper that we started with, there are a lot of equations. Anybody download our paper? It was downloaded by 200,000 people. So what did you think? Equation 2? Can you reproduce equation? I couldn't reproduce equation 2 either.
She says maybe tomorrow.
Maybe tomorrow. It's this really fun combination of we think in entirely different ways. It's not just that we do different things, but we think in different ways. And I really feel like that me trying to understand how Konstantin thinks and having to learn to think that way too, and you the same way, and expanded both of us till we could. I don't think we could have done this without.
That's right. I mean, with
process.
most collaborations, right, it's sort of just a group effort where everybody comes in and they do some part of the project. I think with this collaboration, neither one of us could have attained the goal without the other. So that's the special thing, and that I think that part of what has made this possible is actually our special department at our rather special institution.
Just down this little special street here.
That's right. We're a couple doors away from each other, and we talk nearly every day. It's a tightly knit, kind of concentrated place, and it's so wonderful to do what we do and get paid in American dollars at the same time.
I suspect Caltech is pretty happy to have both of you around. So we're going to move on to another section of our discussion, and we're going to bring up one more guest. But before we do that, the only disappointment that I have tonight is that the Planetary Society's Director of Science and Technology, who is almost always with us for these Planetary Radio live shows, it's Bruce Betts. He was unable to join us. Now, Bruce, if anybody listens to the show, you know he's on every week, so we'll be recording the session with him a little bit later. It's a shame he's not here, but we have the next best thing. He sends his regards, and we also have a little something that he does for the Society. It's one of his really excellent random space fact videos, and we're gonna roll that for your enjoyment right now. Give you an idea of just how huge our solar system is.
Random Space Fact! The New Horizons spacecraft set a record when it left Earth at the highest speed of any human-made object, over 58,000 kilometers per hour. Still, it takes 9 years to get to Pluto. But at the speed it left Earth, you could go from Pasadena, California to New York City in 4 minutes.
Whoa! Hey now, watch it, buddy.
Only in New York, am I right?
So Bruce Betts with one of his many random space facts. Bruce actually created that series with the Planetary Society's videographer and now creative director, Merk Boyan, who is, where are you, Merk? There he is, over there on the corner. A little hand of applause, please, for those guys. Random Space Fact and scores of other Society videos are part of Planetary TV, which you can find at planetary.org/TV. We're going to bring up Linda Spilker in just a moment, but first I want to get the help of you folks in the audience here at the Crawford Family Forum tonight. Like I said, Bruce is on every week. We also do Random Space Fact at the end of each episode of the radio show, the regular radio show. And we love it when we get a celebrity introduction to Random Space Fact. So I'm going to look to you guys. It's your chance for your moment of fame tonight, because I will use this in the show. And the whole point of this will be to see if we can get Bruce to crack up when I play it for him. So if you're ready, on 3, it's going to be, I want to hear you say, "Hey, Bruce, I got your Random Space Fact right here." You ready? 1, 2, 3.
Hey, Bruce, I got your Random Space Fact right here.
Nicely done, nicely done. It's nice that we just had the New York cabbie Fireflies there as well. That fits really well. Linda Spilker has been my guest on Planetary Radio more than any other person. Our last conversation about the magnificent Cassini mission at Saturn was just 3 weeks ago. You can find it at planetary.org/radio. You can hear it, and it was just 2 weeks earlier that I had those guys, Mike and Konstantin, on the show. It's SoundCloud, iTunes. We're on about 140 public radio stations, and they're pretty good conversations. Linda has been part of the Cassini team for nearly 28 years, I think. She became the deputy project scientist almost 20 years ago. She became the project scientist in 2010. And that means that she's basically in charge of all the science being done by that amazing mission. She coordinates the work of all those scientists all over the world. They are already planning for the mission's grand finale next year. Please help me welcome to the Crawford Family Forum stage, JPL's Linda Spilker.
Great to be here, Matt.
We're very happy to have you. I always love having you on the show. Before we get into this sort of broader stage of the discussion, excuse me, talking about our very diverse solar system, Cassini played a part in this unfolding Planet 9 drama.
That's right, that Cassini has been at Saturn for over a decade and very precisely knows the position of Saturn. And so what some authors did is they put in a Planet 9 along with the position of Saturn and tried to minimize any errors or residuals and to try and pinpoint where in its orbit Planet 9 might be. And there's a zone that they show in their paper in green where it might actually be not near the closest point of its orbit, but a little bit further out. So it'll be very interesting to look at that region and see what turns up. And they even suggested it'd be great if Cassini could last until 2020, but that's not going to happen.
No.
2017 is our final year.
But if it goes to 2020, they can really pinpoint it quite well. You sure you don't want to just a little longer?
And we should say the reason it's not going to make it to 2020 is that everything's going to end in 2017, unfortunately, but you have no choice.
Right. Basically, the fuel light is on Cassini. We don't have very much fuel left. And for planetary protection reasons, there's 2 worlds with liquid water oceans, Enceladus and Titan. So what we're going to do is we're going to actually dive in between the rings and Saturn, orbit in that region 22 times, getting incredible data. And on that final orbit, we'll get a little push from Titan and actually plunge into Saturn's atmosphere and burn up, and that'll be the end of Cassini. So we know September 15th, 2017, I think it's about 4 in the morning, that'll be Cassini's finest and final hour.
We're going to be partying, I can tell you.
Yeah, let's do it.
Guys, what do you think of the fact that this spacecraft out by Saturn, almost next door compared to Planet 9, is able to contribute to the effort?
You know, it's such an incredible thing. The model that was used to do this is itself just a huge kind of feat of modern day computation. I mean, it included not just the planets, it included the asteroids, and it solved general relativistic equations. So all of these little asteroids are flying around there, bending the space-time continuum, and that's the level of detail at which we now operate in the search for Planet 9. The fact that introducing Planet 9 actually reproduces the true orbit of Cassini better is, I think that's pretty compelling. That's a separate line of rather compelling evidence for the existence of Planet 9.
You know that every time you mention general relativity, Albert gets another pair of angel wings. Linda, if we just looked at Saturn, as Cassini has been doing for so long now, we'd have a pretty good demonstration of how diverse the solar system is, wouldn't we?
Absolutely. You look at Saturn and the rings and its moons, and you almost have a miniature solar system right there in the Saturn system.
We're going to give more evidence, I should say, of the diversity of our solar system. And we're going to turn this also into a bit of competition for the audience here in the Crawford Family Forum. We've got a series of images, which we will talk about a little bit. But when these appear, if you in the audience think that you know what object we're looking at, raise your hand. Don't shout it out. And if I call on you, and you're the first person to get it right, you will win a Planetary Society rubber asteroid. So let's get started with the very first image. We're going to pop it up there on the big screen. Okay, folks, what are we looking at? I think Dave Duty is disqualified. And professionals right in front there. Hi, ma'am. Io? Nope. In the back there, sir. He says Mars. Are we correct?
It sure is Mars. It's maybe Mars not as you recognize it, because it's a very cloudy Mars, but Mars has weather just like Earth does, so that's Mars.
Thank you, Emily, and thank you, sir. Here is your rubber asteroid. I do not have Bruce's arm. I have no arm at all. Anybody have a good arm? Somebody's got to be better than me. You want to try it? Throw that out there. Oh, he made it easy. All right. Emily, what else can we say about this world, this one that is getting so much attention?
Well, it's getting a lot of attention because it has a lot of spacecraft, but possibly the most exciting thing to say about Mars this week is that on Monday, the European Space Agency will be launching a new spacecraft, a pair of spacecraft toward Mars, the ExoMars Trace Gas Orbiter and the Schiaparelli Lander, which is their second attempt to land on Mars. It's going to be exciting, so watch for that on Monday.
Okay, let's go on to our second image. Easy one, so simple. Yeah, really. Every hand ought to be up for this one. How about over here? How about, ma'am, you on the end there, in front. Oh, what the? Go ahead. You. Sorry, Jupiter is.
It is Jupiter. Congratulations. Whoop.
Oh, okay, I'll take over.
So Jupiter's very exciting because there's a spacecraft on the way that's 100 and something days away from Jupiter. It enters orbit on July 4th. That's the Juno spacecraft. Juno will be the first spacecraft to orbit over Jupiter's poles. So we'll get these top-down and bottom-up views of Jupiter from the JunoCam camera, which is it's a public engagement camera. It's not there for the science. The science is interested in the interior of Jupiter. JunoCam is just there to take pretty pictures that we can all enjoy.
Could you imagine, any of you panelists, worlds that are more different than just the first two that we've already looked at?
You know, I should also, the other reason that Jupiter is cool is because it's right about there right now in the sky. So when you walk out the door, you'll see a big bright thing. That's Jupiter up in the sky.
Actually, I should have said Happy Opposition Day. Jupiter's at opposition today.
As Bruce Betts mentions on this week's Planetary Radio program. But again, could you imagine two worlds that are less alike than Mars and Jupiter? You could.
Yeah.
I could.
Okay, let's go on to the next one here. Gets a little bit tougher. Everybody on stage seems to know. How about you, young man, right there? He says Europa.
Well done.
Nicely done. They bounce, fortunately.
So,
okay, I'm going to do the next one.
Yeah,
Go ahead.
please. Europa. Well, actually, you know what? Mike, tell us about Europa.
Europa is totally awesome. So I spend about, when I'm not out searching for Planet 9, I spend my time looking at Europa, and you can see some of the cool stuff about it. Even just on that picture, it's got an icy surface. It's got this weird red stuff on it. We think a lot of that is salts that come out of the interior. And there is a mission being developed that's we'll get there sometime after I'm dead, probably. But
no, maybe in the 2020s. You're going to
maybe
be
in the
around a long time.
2020s. Okay, maybe it'll actually get there soon. But it's going to be cool stuff. There might even be, keep your fingers crossed. There might even be a lander that will go land on the surface and see what this crazy ice world is like. That would be just awesome.
I just want to throw in, because otherwise my colleague Casey Dreyer, the director of space policy for the Planetary Society, he's also in the room someplace. There he is back there. He would want me to say that Congress has actually written into law that the mission to Europa must be both an orbiter and a lander. Not exactly sure how that's going to happen yet, but wouldn't that be a heck of a thing? So anyway, good thing to support. Let's keep going. We got a lot more of these. I'm going to try tossing the next one out. Here's yet another world, not too far from the one you just saw. What are we looking at, folks? Hands? Right back there, miss.
You are correct. It is Io, and
No,
you can
it's
tell
pronounced
because it
Io.
has that awesome. That's a Tavashtar, correct?
I have no idea.
I don't know which one it is, but this is an interesting Io image because it was not taken by Galileo, it was not taken by Voyager, it was taken by New Horizons while it was on its way to Pluto. New Horizons got to Jupiter after only 1 year. It took a further 8 years to get out to Pluto. So that just tells you how far things are in the solar system. And that's the near inner solar system as opposed to the far part of the inner solar system that you guys are exploring right now.
And I don't think you ever actually said, I mean, that plume, that's a volcano.
It's an active volcano.
Most volcanically active place in the solar system, right?
Mm-hmm.
Yeah, pretty cool. And here is your asteroid. Right
Nice
to
catch.
it. Not better than I expected. Next image. Okay. Let's just, oh, what the hell. All these new hands have gone up. You, sir, with the cap. Say it again? I don't think so. Is that correct? No, that's not. I'm kidding. Here you go. There's your rock. You want to get that back to him there, please? Of course, that's Saturn. Linda, tell us about this image.
Yeah, this is an incredible image. It's one of the few times when the sun is actually covered up by Saturn, and Cassini could take this set of images, create this beautiful mosaic. You can see all the rings, the outermost E ring, fed by the plumes on Enceladus, G ring, the rings, and then you can see, if you look very carefully, there's a very bright ring around Saturn, and that's the sunlight scattered around the atmosphere, and you're seeing every sunrise and sunset on Saturn. And you even notice that the dark side of Saturn is illuminated, and that's light reflected off the lit side of the rings onto Saturn's night side. And so just an incredible image. And if you look very carefully, there are 3 other worlds in this image.
Let's go to the next slide. That's why.
And there they are. You have Mars, Venus, and actually a picture of the Earth and the Moon. And in fact, we went out to the public and said, okay, at this time, in this 20-minute window, we're going to take a picture of the Earth and the Moon, a series of pictures. So go out and wave at Saturn. Here it is in the sky, and send us selfies. And we actually took those selfies and recreated this mosaic. So we had a lot of fun. So how many people here were out waving at Saturn? It was July 2013.
I was there with a few hundred people at JPL. It was a blast. You even allowed for light time for the
That's
image,
right.
didn't you?
That's right. So the
Yeah.
photons from you would reach the Cassini cameras at the right time.
And I think we
a little over an
calculated-
hour later. So
I think we calculated that if you were outdoors for the whole 15 minutes and waving at Saturn, that there is a 1 in 20 chance of 1 photon from your body getting out to the camera.
One more image in the series. We'll go in for a close-up here. There they are down in the corner. That's everybody you ever knew, or as we know Carl called it, the pale blue dot and its close companion. Okay, next image. These are also images that Linda kindly provided us, and unfortunately it gives it away. I didn't even stop to think about that. She's got labels. Okay, let's talk about these worlds, beginning with the one on the left there, which has a lot in common with Europa, doesn't it?
yes, it's an icy world. It's a lot smaller. It's only about 300 miles across. And Cassini discovered that you can see those bluish fractures at the South Pole. And there are jets of material, curtains, geysers coming out of the South Pole, mostly water, but you've got organics, you've got carbon dioxide, nitrogen compounds. Very fascinating place. Some of those particles fall back like snow. That's why Enceladus is so bright. And a lot of them go out to form the E-ring. So Enceladus is orbiting in the midst of a ring that's it's creating. Very fascinating place. We wonder, could there be life in the ocean underneath the icy surface in the same way we wonder about Europa in the ocean underneath its icy crust?
One thing I think that's cool about this picture, it was taken fairly early in Cassini's mission. Cassini arrived at Saturn when it was summer in the South Poles, and now Saturn orbits very slowly. Now we're getting it at winter in the South Pole, and so we can't see those stripes with regular sunlight anymore, but I know that Cassini can see them in a different way.
Right, we can look in the infrared and actually measure the heat coming out of those tiger stripes, and that's what we did on our very last close flyby of Enceladus in December, measuring the amount of heat coming out to tell us what activity might be going on in the ocean. We think there might be hydrothermal vents on the seafloor of Enceladus, hot activity bubbling up, and so we're getting clues by looking at Enceladus South Pole in the dark as well.
How about that other very different world?
Very different, that's Titan. Titan's about the size of the planet Mercury. It's the biggest moon in the Saturn system, has a very thick nitrogen atmosphere with methane in it. And on this particular world, methane plays the role that water plays here on the Earth. You get methane clouds, methane rain, methane flows through the river channels, fills some lakes and seas at the North Pole of Titan, a very fascinating place. It's very cold there and yet eerily familiar. You've got dunes at the equatorial region. Looks a lot like home, it's just a lot colder.
Konstantin, you're a planetary atmospheres guy. I mean, what about this world?
Well, it's interesting. Titan is the only place in the solar system where you could go outside, and if you were really bundled up, because it's only 90 Kelvin, right? So it's minus a big number in Celsius. It's colder than Siberia. That's kind of how I gauge it. And you had a little bit of, you put in some oxygen. You could be just fine. It's got a nitrogen atmosphere, so you could, with a little bit of oxygen, breathe it. It's got a pressure of about only 1.5 times greater than that of the Earth. So it's a very fascinating place to be.
The detail I like about Titan's atmosphere is that it is similar to Earth's atmosphere, but Titan has a lot lower gravity. So if you, in addition to your suit needing a little warm, a little oxygen, you just had a pair of not very big wings, you could just sort of flap and you could fly on Titan. And I think that would be really awesome.
I'd be wearing gravity boots, just like kidding.
I knew I should have worn my Surf Titan t-shirt. Let's go on to the next image, which I think is not labeled. This actually jumps back a little bit. Somebody's got her hand up. Hi, what are we looking at? Enceladus? You are absolutely right. And here is your asteroid. Whoop, I almost made it. It's all right. Did it go under the stage? Thank you for helping out. There are people who kind of wish there was a mission to Enceladus just like the one that's planned to Europa, right? Emily?
Yeah, one of the wonderful things about Enceladus is that we would love to be able to sample these oceans, but most of these ocean worlds have their oceans buried very deeply inside them where they're hard to get to. But Enceladus is extremely helpful. It's spewing its ocean right into space. All you have to do is fly by. Very easy.
Right, fly through it. Cassini has done that 7 times. We went very close and sampled the material coming out of the jets and plume, and that's how we measured the composition. But with Cassini, we didn't know we'd find this plume on Enceladus, and so it would be great to go back with a modern instrument that could really answer some questions that we've left with Cassini.
And when I said there are people who'd like to see a mission there, you started going, me, I want to see that mission.
Yeah.
I don't know. Mike, Emily already said, you also spent a lot of time looking at Europa. How would you balance the two?
Oh, I definitely go to Europa. Much more interesting.
Oh no, I disagree.
I'm not balanced at all.
Free samples coming out.
So they are similar in some ways, but they're also very different. I would go to both. It's true that you could, if all you care about is what's inside the ocean, this is the easiest way to get there. If you would just like to see if there are little fish being spewed out of the South Pole, this is the place to go. Europa has, in Enceladus too, they both have a lot more interesting things going on too. So I think it's actually, I would go to both. And I think that there's a good chance that this one mission is certainly being planned to go to Europa. There is a chance of one going to Enceladus relatively soon thereafter too. So I think that would be great.
Right,
Yeah.
There's a New Frontiers program, and they've added recently the ocean worlds Enceladus and Titan. So it's possible to propose a mission to go back to these worlds now, which is very exciting, and it's based on all of the findings made by Cassini.
The Ocean Worlds Initiative, another thing I got from our Casey Dreyer. Next image, let's see what's up next. Okay. Once again, we jump back a little bit. Details on one of those worlds we've seen back there in the glasses. Hi, sir.
That is Titan. What's the name of this?
That's
body?
Ligeia.
No, don't. That's
I wouldn't
okay.
have gotten that
Go
one,
ahead.
so-
That's Ligeia Mare. It's about the size of one of the Great Lakes here on the Earth, filled with hydrocarbons with methane. In fact, if you could bundle up all the hydrocarbons in the lakes and seas on Titan, you'd have about 100 times more than all the reserves we have here on Earth. So if we could only make that pipeline from Titan, we'd be in great shape.
This is never going to work, but let's give it a try. Oh, almost made it. Oh, sorry about that. At least they're rubber, right? Next image. Great comparison. Nobody has to identify these. But this is pretty cool, and it comes from Linda.
Yeah, it's just comparing the size of all of these ocean worlds to the size of the Earth. And you can see Enceladus is the very tiniest. And then you've got Titan and Ganymede and Callisto. Ganymede and Callisto are at Jupiter. You also have Europa there. And you notice at the bottom another moon, Triton. Now, Triton orbits Neptune. And when Voyager 2 flew by Neptune in 1989, we saw geysers actually coming from the surface of Triton. So we wonder if there might be an ocean of some sort underneath its icy crust, or some process is going on to generate these geysers.
One of my favorite facts about these ocean worlds is the comparison between Earth. You know, Earth is huge, Europa is relatively tiny, but it turns out that the oceans on the Earth are not particularly deep, and the oceans on Europa are. So there's a good bit more liquid water on Europa than all of the liquid water on the Earth, which is just kind of amazing.
What's the current thinking about how deep, how thick that ocean, the liquid portion of it, is under the ice on Europa?
On Europa, boy, I'm going to have a hard time remembering the exact number down there. But it goes basically from a very thin shell, just maybe a couple tens to 100 kilometers deep, all the way down to a rocky core. So it's maybe half of the radius of the body itself. It's mostly water. It's kind of an amazing thing.
All these moons are actually made mostly of water. It's just it's water in different states depending on the depth and the pressure and everything. One of my favorite things that I learned recently is that Ganymede may have more than one ocean with different types of ice perched in between them. So they call it, I forget now who did this work, but he called it the club sandwich model of Ganymede's interior.
I also love that on Titan, you've got a choice of the surface ocean, all those hydrocarbons, or you can dig down and get to the water, right, Linda?
Right, there's a water ocean, we think, underneath Titan's icy crust.
Okay, we got a few more of these. Before we go on, though, I'm going to talk to the webcast audience. Hope you're enjoying the show, first of all. And we're going to give you a chance to get in on this. If you're not already watching the show on the Planetary Society website, that's where we are ready to take your questions. And our communications manager, Andrew Pauly, is sitting in the back there of the room. And we're going to be going to him in a few moments. He's going to sort of filter what you submit a little bit. You can do it right there in the comments at the top of the Planetary Society page, Facebook page, where he has pinned the player for the program tonight. You might want to use hashtag Planetary Radio Live, and that'll even give it a better chance of getting right to us. So we'll go to Andrew when we go to the audience that's here with us in person in the Crawford Family Forum in a few moments. But we'll get through a few more of these first. Let's go to the next one. Ooh, this was my choice to include because it gives me the creeps, as it does a certain percentage of people who, when they see a shape like that, are creeped out. Anybody else kind of get that? It's like, no, I'm just the weird one again. Okay, who thinks they know what this is? Who have we not heard from? Way in the back there. Yes, sir.
Is it the Rosetta mission?
No, I can tell you up front, but stay tuned. Anybody? Anybody? Yes, sir. No. Good guess.
Kind of
Good
looks.
guess,
It
though.
looks.
Yeah.
That's not a bad
Yeah,
guess.
it does kind of resemble it a little bit. Okay, we'll give it away. Oh, wait, we have another hand up? I missed? Way in the back corner there, yes. No. He did say Sedna, right?
No, he said Vesta.
Oh, Vesta. No, sorry about that. Emily, let's give it away.
It's Hyperion. It's Saturn's chaotically rotating moon, which didn't look anything like this when Voyager looked at it from quite a long way away. And it was only when Cassini saw it up close that we realized what a strange world this is.
I think it's very fluffy, very porous, kind of nicknamed the SpongeBob moon. You know, it looks like a giant sponge.
I think of it like a wasp nest, which is why it creeps me out.
My favorite thing about Hyperion is that because it's chaotically rotating, you can't really figure out what face is going to be presented toward your camera when you're taking a photo of it. Cassini's flown past it a few times, and every time Hyperion has chosen to show us the same side. So we don't know what the other side looks like.
Maybe it looks exactly the same.
It's just shy.
Yeah.
All right. Are we demonstrating adequately that we live in a pretty diverse neighborhood? I think so. You ain't seen nothing yet. We got a few more of these. Let's go to the next one. Big guy. What are we looking at here? Somebody we haven't heard from yet? Did we? You not yet. Go ahead. Right up in the front. Correct. I don't know. You're going to get a talking to when you get home because this is Konstantin's wife right here. Answered that one. No, I'm sorry. That's not correct. Ma'am, in the back, right there at the light hair. Yes, go ahead. No, I'm looking at you with the highlights. Yes. Sorry? Neptune? Yes?
Neptune. Yes, that's Neptune. It's our most distant large planet, and my favorite fact about this photo is that
no, it's not. No.
We haven't found that
true.
one yet.
Just because we haven't found it doesn't mean it's not.
So my favorite fact about this photo is that dark spot is not there anymore. And every single photo portrait of Neptune shows you this great dark spot. There have been other dark spots, but not that one, and it may or may not be there right now.
Linda, why do we need a mission out to this guy and its neighbor Uranus?
Oh, well, those are the ice giants, and it would be so interesting to compare these two worlds to Jupiter and Saturn, the gas giants. They're very different. They're smaller. How did they form? How have they evolved out to their positions? For me as a ring scientist, they each have fascinating ring systems to go back and study, their own set retinue of satellites, so really intriguing to go back to either Uranus or Neptune. I happen to like Neptune because it has Triton. You get a chance to look at Triton.
All right, shield your eyes. Turn away like Hyperion. I'm going to try and get this back there. It's not going to work.
Ooh, not too bad.
Not too bad, not too bad. Okay, let's go to the next one. We're almost through these, I think. There's an interesting body. Linda knows. Anybody want to guess? We really ought to give you more if you get this one. Oh, and wait till you see some of the others. No? All right, Linda?
It's Miranda. Uranus's moon Miranda, very unusual. It looks like it's been torn apart and put back together. And with the Uranian satellites, we only saw one side. Uranus looked like a giant bullseye during the Voyager flybys, and so we really just saw one side. So wonder what the other sides would look like.
So this is sort of an example of why I'd rather go to Uranus than Neptune, because Miranda is just one of many very interesting moons there. This one happens to be the same size as Enceladus, and it looks different in some ways, but kind of similar in others. So you sort of wonder if some of the stripy things are caused by the same mechanism that made the stripy things on Enceladus.
Right. Interesting tectonics for sure.
Is it Miranda or one of the others that has the highest cliffs we've found in the solar system?
I think it's Miranda.
Yeah.
And they're right there on the edge of the disk at about 2 o'clock.
Next image. See if anybody can pick this one up. Okay, this one's been in the news.
You have to pronounce it correctly or you don't get it.
I only see one hand right back in the middle there. Yes, sir. Hard to say, isn't it? Emily?
It's comet Churyumov-Gerasimenko, but you know what you were talking about. That is the correct answer. This is the comet that Rosetta is exploring. It's still there, and Rosetta is actually going to come in for a landing on this thing in September of this year.
Very cool. And even now, Rosetta is closer than it's been, right?
That's right, and Rosetta is now checking out the comet's southern hemisphere, which is newly exposed in a summer sunlight. After the comet went through perihelion in August of last year, and it was a little bit difficult for the spacecraft to get very close to it at that time. But now it's a lot farther away, it's a lot less active, and the spacecraft is much closer and checking it out in more detail.
A tremendous achievement by the European Space Agency. So congratulations once again to them. Next image.
This is the last one, I believe. This one is really a stumper.
Yes, this is not the Death Star after it was destroyed.
I'm going to challenge people on the stage to answer this one.
Well, I know it's one of, I don't know which one it is, but I could.
Okay.
What, is it one of yours?
No, it's one of the moons of Pluto, but I don't know which one it is.
You're all wrong.
It's not one of the moons of Pluto? No, it's not like Nix or Hydra or something?
Nope, I'm afraid not.
I
No, this
am.
one is Thebe. Thebe
No.
is one of
believe it.
Jupiter's inner ring moons. It's in a position right outside all of Jupiter's rings, so it's kind of like Janus or Epimetheus in terms of size and position in the Jupiter system. And this is the greatest image we have ever taken of it. It's not very good, and it's an example of why. Well, it's awesome if you're a ground-based astronomer, but it's not very good.
Standards are very low.
If you're exactly, it's not very good if you like. If you're an orbiter person.
What is
better.
what is up with that crater?
It is a big crater, but
It's like, how could there even be a crater that big without it not being shattered to pieces?
it's an interesting thing about a lot of the moons of the giant planets that they all seem to have a crater that is just not quite big enough to have blown it apart.
It's amazing.
So what's the size of this thing?
I don't know.
Like
It's probably only of maybe 10 or a few tens of kilometers. It's also the source of a lot of ring material. These tiny inner moons at Jupiter, a lot of dust comes off of them and forms a very extended set of rings at Jupiter, very dusty, very tenuous.
And these little worlds like this at Saturn as well, they have a lot to do with sort of corralling the rings, right?
Right, and the structure in the rings is driven by gravitational interactions with the tiny moons that are very close to the rings at Saturn.
I think we have at least one more. There it is. Why? Because, as you heard from Mike and others, there's more out there waiting to be discovered. Anybody want to argue with that? No. It's too obvious to even talk about. So, you're all pros at this. Do you still take time to marvel at just how wonderful a neighborhood we have? Anybody?
that's all we do actually. Most of them, that's like good fraction of what we do.
So as I mentioned a couple times, I was up on Mauna Kea at the Subaru telescope on Friday, and yeah, you're there. It's incredibly busy. You're up at altitude. You're sleep deprived. You're working really hard, and still always take the time to get out. They have these great night vision binoculars. You go out and just stare at the sky, and you can see everything out there for 360 degrees around, and just remember that you're in this incredible place in the universe looking out, and you can't forget that any time you're there.
Yeah, the diversity in our own solar system makes me wonder what else might be out there around other stars, the exoplanets. Are they going to be equally as intriguing when we get a chance to really look more closely at those?
They are. They will be.
And the thing that I marvel at is that we have about 20 robots, semi-autonomous robots out there exploring all of these different worlds, sending us images as we speak. You can go see which spacecraft are downlinking data right now at this awesome website, Eyes on the Solar System from JPL. And in many cases, especially with Cassini is one of the shining examples, you can see pictures that spacecraft took just hours ago sometimes. You can go to the JPL website, see brand new images fresh from Saturn, and it's just a wonderful gift to all of us who are space fans. So thank you for that.
Oh, I agree. That's great.
To paraphrase Ray Bradbury, we are the Martians. That's a quote. To paraphrase him, we are the Saturnians, we are the Jupiterians, we are the Venusians, the Mercurians, you name it. We're the ones who are out there exploring. And the Sednians. And the Quarori. Let's let our audience here in the Crawford Family Forum get in on this. If you have a question, raise your hand. Somebody will come over with a microphone, a wireless mic. And please do keep it as succinct, as quick as possible. And we'll turn it over to our extremely distinguished panel up here on the stage. Anybody? I'm shocked. We have somebody right up in the front. We've got somebody over here on the side. Don't be shy. We'll go up in the front here. Over here on the side first. There she is. Hi, introduce yourself and let us know your question.
Hi, my name's Carmen. My question is, if and when you guys do find Planet 9, what would you guys name it?
Good question.
So there's a petition out there on change.org. Don't sign it. It's addressed to the two of us plus the International Astronomical Union to name it David Bowie.
Change.org.
So we've seen enough emails that really demand that we name it Planet Bowie, that it's starting to look like a real good idea. We're going to get moons, we're going to get Major Tom, Ziggy Stardust.
Ziggy, yeah.
We've got this all planned out.
So we do have a semi-serious answer to that question. Oh, we have many non-serious answers, including George. We've been thinking about George a lot because Neptune was supposed to be George and Herschel didn't. I'm sorry, Uranus was supposed to be George. But the one thing that we really think would be an interesting and appropriate thing to do is to allow it to be named by and for the people who are where the telescope is that discovers it. So it might be discovered in Hawaii. I would argue that it should be given a Hawaiian name chosen by the native Hawaiians. It might be found in South America. It might be found by a spacecraft. It can be named by aliens at that point. So I would like to see that happen, and we'll see what really does happen. But that would be my hope is what we can do.
But really, we'll name it Bowie.
George.
I don't know. My 5th grade class, I told you guys, they thought Cupid would be good, but you shot it down.
Yeah. Well, it'd be depressing if Cupid only came around every 20,000 years.
That's true. Any other questions from here in our audience, right up in the front? Hi, introduce yourself. There's the microphone.
I'm Don from within walking distance of this place. I guess I missed what made you think there was this ninth planet. I heard you talking about the perturbations on one of the other planets, but that didn't seem to be it. And how come you don't know more about where it is in this orbit?
Yeah, so I guess why can't we pin it down better than we have?
So that's an excellent question. Our first line of evidence, really was the way in which these objects that are out there are assembled. And this is what really initiated the project. To give credit where it's due, Mike came into my office a couple of years ago and said, have you seen this? Have you seen this? And what he was pointing to was essentially the fact that all of the orbits were swinging out in the same direction. That if you just leave that system alone within the framework of just the known planets, that alignment goes away. So we sort of, right away kind of infer that something gravitational is going on. Why do we not know where it is? Well, there's a substantial difference between how Leverrier found Neptune based on perturbations to Uranus and how we are going about finding Planet 9. In effect, by the time Leverrier began his calculations in the early 1840s, there was enough data to backtrack one full orbit of Uranus. So you could see the deviations from the predicted path of one full orbit of Uranus. With the Kuiper Belt objects that we have today, they move so slowly, all that we really know are their orbits, right? They haven't moved much in the last 3-4 years. If you're willing to give us, 5,000, 10,000 years to watch them go around their orbit, and I will, by the way, or at least I'm planning to live on as a cyborg forever. So I will redo this calculations eventually. But that's the missing piece. We don't have a movie. All we have is a snapshot. And from a snapshot, all we can learn is the orbit of Planet 9, not its location in its orbit.
And we don't even need. I don't think we need the Kuiper Belt objects. If we had Cassini at Saturn for 30 years, and watched watch Saturn in a full orbit for 30 years. I actually suspect that would be enough to track it down too. But Cassini was only there. The data so far, it's only been about 10 years. I think a few more years they'll get the data. So it's only a small part of its orbit where it was moving. So we didn't get to really sample all of the parts of where it might be.
Shame we can't run a bit more gas out to.
Can't you
Cassini,
guys just
isn't
up
it?
your
It would be
gas
great,
mileage?
like tap into Titan or something,
Nope. You know what? You don't have the microphone anymore, so we're going to hold off because I know Emily's got a question too.
Yeah, actually, there's something about your paper that disappointed me.
Well, there's only
And
one
here was-
thing.
There's just one thing. So your paper, you explained several peculiarities about these things in the Kuiper Belt.
Oh, I know
and
what she's gonna say.
one of the ones that I wished it explained was why. So the Kuiper Belt starts at about 30 AU, and we know why it starts there because that's where Neptune is, and it kind of clears things out. But it ends at about 50, and I was really
47.
hoping that you would explain that, and you didn't.
You know, it still might be in the stars to explain away the so-called Kuiper cliff. You know, it's not something that comes out of our models naturally with the current orbit of Planet 9. Planet 9's orbit, however, likely evolved over the lifetime of the solar system. Maybe the two are connected. The story we wanted to tell was only one that's grounded in the observational reality that is current. So you know, I agree it would be awesome, but you know, well, let's find it first.
What Emily's also getting at is that it is true that many of the previously unexplained features of the Kuiper Belt are explained by the existence of Planet 9, and I think I made the statement at one time that, you know, everything about the Kuiper Belt will eventually be explained by Planet 9. And Emily immediately said, what about the cliff? I'm like, So we'll get there eventually. What I always tell Konstantin, I walk in his office and I'm like, this is all good, but until we can actually make Planet 9 explain the parting of the Red Sea, I'm not satisfied. So we're working on that too.
Yeah, I'm just molding those equations.
Yeah.
Emily Lakdawalla, planetary evangelist and solar system troublemaker. I want to get to Andrew Polly, the Planetary Society Communications Manager, who's in the back of the room there. Andrew, did anybody get to the Planetary Society Facebook page and drop us a question?
They sure did. We actually had a couple of duplicates of questions from the audience, so there's a lot of common interest that's already crossed over, but I will give some of the unique ones. First off, starting with Zoe from Twitter, she asks, what mineral, if any, would be most abundant on Planet 9?
Interesting. The mineral.
The water mineral. The water and the rock and the hydrogen helium mixture. No, that's a great and confusing question because I'm just a simple physicist. I just don't know anything
So
about
probably
minerals or nothing like
I'll
that.
try to save you, Konstantin. The most common minerals in rocky worlds are things that are made of iron and silicates and magnesium. So you have things like pyroxene and olivine, but when you squeeze them under really high pressure, they turn into different minerals, things with names like perovskite and stuff like that. So
I think we're well beyond those pressures.
So we might even be into minerals that we haven't
Post-perovskite.
played with yet, which is really cool.
Post-perovskite.
But we'll also have ice in many forms, and including ice 2 and ice 3 and ice 4 and ice 5. And there actually is something called ice 9, and it doesn't do what Vonnegut says it
Any
does.
Vonnegut fans, Kurt Vonnegut fans out
But-
there?
but
You don't
probably
wanna-
Planet 9
Don't bring
has
any
Ice
Ice 9 home, that's all I can tell you. If we want to get a mission out there to any of these worlds, I think we need one of you down there to say that one of these is pure diamond. It has a core of pure diamond.
We don't have to go out to Planet 9 to get to the diamond. We think that probably Neptune is raining diamonds.
But no, look, Planet 9 is wearing its bling. It's got diamonds. It's got diamonds and gold chains.
Linda?
Yeah, I think that would be great to get out there. Maybe we need a solar sail, like the Planetary Society. Yeah.
Very good.
We'll see what we can do. Andrew, you got one more?
Last but not least, how long did it take for Planet 9, hashtag Planet 9, I'm sorry, to form?
To form? Guesses?
We think Planet 9 actually formed out of the same material that Uranus and Neptune, and to a lesser extent Jupiter and Saturn, are made up of. And there is a chronometer. There's a stopwatch which basically ends at 3-ish million years after the birth of the sun, after which you are no longer allowed to make Uranus and Neptune and Planet 9. So it's those first few million years of the solar system's lifetime that generated all of the giant planets of the solar system, including its most important member, Planet 9.
I'm kind of partial to that pale blue dot myself. Emily?
I think one of the things that I was reading recently that Planet 9 implies that's rather interesting has to do with the environment in which the sun formed and what Planet 9's continued existence would mean for the formation of our star in our birth cluster. Can you explain that?
Yeah,
to
so
me a little bit?
this is actually something that's been an interesting question ever since we discovered Sedna back in 2003. And the Sedna has a very peculiar orbit. It goes on a very eccentric orbit, but it doesn't come back to the region of the Kuiper Belt. It's well outside the Kuiper Belt. And as soon as we discovered Sedna, we realized that there has to be an explanation to perturb the orbit like that. And that was our first clue. Turns out the answer is Planet 9. We didn't know that at the time. But now that we see Planet 9, it has an orbit that goes out very far, but it doesn't come back to where we think it came from. We think it came from the Jupiter-Saturn region and got scattered out, which means that somewhere out here, it had to have gotten a little bit of a nudge so that when it comes back, it doesn't come back in the same place. So there are a lot of different ways of doing it. One of the ways, which was how we used to think Sedna formed, is to when it's out here, that there are all these other stars that are being born at the same time as the sun, and they give it gentle nudges and change the orbit some. That's one possibility. The other possibility is that there's still gas around, that all the gas hasn't been collected and it's plowing through the gas, changing its orbit some. Yet another possibility that some astronomers have proposed is that Planet 9 didn't actually come from where we say it did, but it actually was captured from another planet, another star that was going by, and it captured it from that star. So maybe Planet 9 is our first actual exoplanet instead.
I want to give one more chance to anybody who's here in the audience at the Crawford Family Forum. We'll get one more question from here because we are very near the end of our time this evening. Sorry, folks, we got somebody right in the back there who's got the mic. Yes, sir. Give us your name.
Yes, my name is Ben. So we know every planet affects each other's gravity, kind of gives each other a wobble. So when you put in Planet 9 into the model, like how do you go about vetting and seeing how it fits with all the wobbling? How does it wobble all the other 8 planets?
It's actually an excellent question, and as it turns out, Planet 9 is dynamically detached from the inner solar system, which includes the other eight planets. The way to think about it is as follows: think of a canister of gas, right? Which you can squeeze. All of the at any one point, if you squeeze a canister of gas slowly, it will change its pressure and its temperature, and all of the atoms inside that canister of gas will be more or less unaware of the fact that they're being squeezed. Only the global quantities, right, that define the property of that gas will change. It's kind of like that, where Planet 9, it takes so long to go around the solar system that it doesn't really change the orbits of the inner planets. Instead, the inner solar system more or less behaves as a plate, and it kind of rotates around. So all of the planets, being concentric and planar to themselves, kind of process around very long time scales. So the short answer is, we really can't detect the effects of Planet 9 upon the planetary orbits unless we'd make a video that's 5 billion years long.
Which in a sense you can do, right? On a supercomputer.
Yeah, in fact, that's actually those are the kinds of calculations that we do. We form a solar system which is initially randomized, and then we evolve it forward in time for 4 billion years, and then we compare the synthetic solar system that we create in our computer models to the real ones, and we basically use that process to infer what is the real orbit of Planet 9. It's a lot of fun.
We're gonna be in bonus time here in a moment, but I feel guilty because I figure we ought to go to the center section here where there were some other people who had questions. Right on the end there, Miss. Hi.
Hi, my name is Sarah, and I'm from Los Angeles. I was wondering why objects in the Kuiper's belt, how come they don't fling? I mean, what before you discovered Planet X or
9,
whatever we want to call it, maybe might be there. Why? What was your explanation to why they don't fling outside the orbit of the sun?
So it turns out that the sun's gravitational pull is so strong that things could be 100 times further away still and be in orbit around the sun. So as long as there's nothing else happening, if you put an object on a very eccentric orbit like that, even a 10,000, 20,000 year orbit, it will just go around the sun minding its own business for 20,000 years and nothing will happen to it. And so it's not true that nothing will happen to it. It'll go around the sun like this and slowly it'll change the position of its orbit. And that's why the fact that all of these had the same orbital position was so strange and unexpected. But you could go out much, much further and still be very, very strongly connected to the solar system in orbit around the sun. The only way to fling yourself out is to come in, maybe get a little bit too close to Neptune. You know how anytime we go send a spacecraft out to the outer part of the inner solar system, that would be Neptune or something. We always do a slingshot past Jupiter. So the same thing can happen to your Kuiper belt object. It can get a little bit too close to Neptune, get a slingshot, and then if it does that, it can get ejected from the solar system. But as long as it doesn't interact with anything, they'll just go around and around and around forever.
And as far away as this Planet 9 thing is, it's still way closer to us than the Oort cloud,
right,
which is part of the solar system and where all the comets come from. So the solar system occupies a really, really, really big amount of space.
And just to add to that, it's interesting, sort of related to this question, the early solar system had a Kuiper belt that actually was much more massive than the one we have today, maybe by a factor of 1,000. And in fact, the solar system did lose a lot of mass by Neptune flinging it all out. And this was at a time when the planets had much more eccentric and inclined orbits than they do today. And actually the reason they are so circular today is that we've lost all of this angular momentum and energy to flinging out, Kuiper belt objects that are, of course, no longer there.
This has just been a blast. I hope you folks had as much fun listening to these people as I have. We are pretty much out of time. Linda, what should we be watching for from Cassini?
Well, I think in just the next day or so, we have an occultation of the Enceladus plume. It's very distant, but it's when Enceladus is at a unique place in its orbit. We know that the emission from the jets and plume vary by about a factor of 3, depending if you're the closest point to Saturn or further away. So this one, at the furthest point from Saturn and Enceladus' orbit, we're going to measure the gas. We've always measured the particles before. We'll see if the gas is 3 times more abundant in this position, and those data should be coming back within the next day or so. So we're really looking forward to that.
And that big finish coming in July, right? Of
Right,
2017?
September 2017.
September, sorry. Yeah. Konstantin, other than nagging Mike to hurry up and find Planet 9, what are you up to?
Well, I'm doing a few things at the moment. I think I'm spending a lot of time refining the theoretical calculations on Planet 9. Any additional piece of data, any additional object in that cluster that Mike discovers is something that we can use to make better predictions, right? Make tighter predictions on what Planet 9, the orbit it occupies. Additionally, I'm spending quite a bit of time trying to understand why the solar system's architecture, the orbits of our planets, all of the inner solar system, is so different from the exoplanets, the systems of exoplanets that have been discovered over the last 20 years.
Mike, I'll just ask again, what can we do to help?
Send money.
Lock me in my office and don't let me out until I find it. So right now, the data are literally streaming from Hawaii to my computer in my office, and as soon as they all get there, I'll start processing. Last week's data may well be in there, and within a month, we'll probably know if it was in that part of the data. But as importantly, as Konstantin said, it's not just searching for Planet 9 itself, it's searching for many other of those distant Kuiper Belt objects. Every new one of those that we find narrows the search window a little bit. So over the next few months, we'll be finding more and more of those and know where to point even more.
Anything else you are up to that you
No,
want to
I'm
share
not
with
allowed
us?
to do anything else right now.
Thank you for keeping him on task, Konstantin. Emily, of course, I look forward to talking to you again next week on Planetary Radio. What's the title of that book?
Well, it's for an academic publisher, so it's not the thrillingest title. It's Curiosity Rover, Design, Planning, and Field Geology on Mars. Tells you everything you ever wanted to know about Curiosity, and probably a lot that you didn't know you ever wanted to know, including such random details as its descent stage carried a used part from one of the space shuttles. And another small part on it was built in at Mount Holyoke College, I just learned this week. I thought that was pretty cool. So lots of random details like that, as well as the story of the exploration across the surface of Mars. And I can't wait to read it.
And when might all of us be able to read it?
Hopefully next year. My due date is in the winter of end of this year, so hopefully sometime middle of next year maybe it'll be out.
All right, 2017 is going to be another big year for the solar system for many reasons. Please help me thank all of tonight's guests, Linda Spilker of JPL, Konstantin Batygin, and Mike Brown from Caltech, the California Institute of Technology, the Planetary Society's Emily Lakdawalla, and the Society's CEO, Bill Nye, the Science Guy. I also want to thank Southern California Public Radio, the home of KPCC, for once again taking absolutely wonderful care of us here in the Crawford Family Forum. Supporting the show tonight for SCPR are Liz Brown, David McKeever, Haley Waters, Jason and Clara Georges, that's his daughter, Ashley Alvarado, Michael Garza, and their boss, the managing producer of Forum programs and live events, John Cohn. Finally, I want to thank all of you who join us tonight, whether you're here with us in the room or watching the webcast all over the world. We'll try to keep it up for you. We've got lots more good stuff for you at planetary.org. And of course, the radio show is new every week. I'm Matt Kaplan, the host of Planetary Radio. Good night, everybody, and clear skies.